Welcome back to the channel. Today we're diving into one of the most misunderstood tools in modern web development, JSON Web Tokens, or JWTs. Developers love them because they promise a stateless paradise where your server doesn't need to remember who is logged in. You just hand the user a signed passport and they show it to you on every request. It sounds perfect, right? No database lookups for sessions, easy scaling, and a clean separation of concerns. But here's the catch. That statelessness is exactly where the trap is set. Many teams adopt JWTs without realizing they've just traded one set of problems for a much more dangerous one. In this video, we'll break down the structural flaws, the implementation mistakes, and why you might actually want to go back to boring old session cookies. To understand the trap, we first need to look at what's inside a JWT. It's essentially a string divided into three parts by dots. The first part is the header, which tells the server what algorithm was used to sign it. The second part is the payload. This is where the actual user data lives, like their ID or email address. Finally, there's the signature, which is a hash of the header and payload using a secret key. It's important to remember that the payload is not encrypted. It's just base64 encoded. This is mistake number one. Many developers put sensitive info like passwords or internal roles inside the payload, forgetting that anyone who sees the token can read exactly what's inside it with a simple decoder. It's a clear text postcard, not a locked box. The biggest trap of all is the revocation problem. In a traditional session-based system, if you want to log a user out, you just delete their session from your database. The next time they try to access a page, they're gone. But with a pure JWT, the session lives entirely on the client. If a user's token is stolen, or if you want to ban a malicious user, you can't easily kill that token. It remains valid until it expires naturally. Imagine a thief steals a master key to your house, but the lock is designed to only check if the key is genuine, not if it's been reported stolen. To fix this, developers often end up building a blacklist in a database. But wait. If you're checking a database on every request to see if a JWT is blacklisted, you've just lost the stateless benefit you wanted in the first place. Then there is the issue of where you store these tokens. Most developers dump them into local storage because it's easy to access with JavaScript, but this is a security nightmare. Any script running on your page, including third-party analytics, chat widgets, or a compromised NPM package, can read your local storage and exfiltrate that JWT. This is called cross-site scripting, or XSS. Once an attacker has your JWT, they are you. Unlike cookies, which can be protected with the HTTP-only flag to make them invisible to JavaScript, JWTs in local storage are wide open. If you're building a dashboard that handles sensitive user data, putting a long-lived JWT in local storage is essentially leaving your front door unlocked and hoping no one notices. Let's talk about one of the most infamous vulnerabilities in the history of JWT libraries, the none algorithm. Remember that alg field in the header? It tells the server how to verify the signature. Now, imagine a lock that has a setting called already open. That's exactly what the none algorithm does. If an attacker changes the header to specify alg equals none and removes the signature, some older or poorly configured libraries will simply accept the token as valid without checking anything. It sounds like a joke, but it has led to massive security breaches. Even if your library is patched, this highlights a fundamental issue. You are trusting the client to tell you how to verify their own identity. It's like a stranger handing you an ID card and saying, "Don't worry, you don't need to check the hologram on this one." Secret management is another major pitfall. For symmetric algorithms like HS256, your server uses a single secret key to both sign and verify the tokens. If that secret is weak, like mysecret123, it can be brute forced offline. An attacker can grab a valid JWT from their own browser and run millions of guesses a second against it until they find the key. Once they have it, they can forge tokens for any user they want, effectively becoming the admin of your entire system. The solution is using asymmetric algorithms like RS256, where the server signs with a private key but verifies with a public key. This is much safer, but it adds complexity that many developers skip because they just want to get the login button working as fast as possible. Finally, we have the stale data problem. Since the server doesn't check the database, it trusts whatever is in the token. If a user changes their email address or is stripped of their admin permissions, that information won't be updated in their JWT until the token expires and they get a new one. This means a user could potentially maintain elevated privileges for hours or even days after they should have lost them. In a security-conscious application, this window of stale permissions is unacceptable. You're essentially allowing the user to provide their own authorization data, which is only as fresh as the moment they logged in. The only way to fix this is to make tokens very short-lived, but that leads to a poor user experience as they are constantly forced to log back in. So, is JWT a total failure? Not necessarily. The trap is using it for everything. The modern, secure way to handle this is a hybrid approach. Use short-lived access tokens, lasting maybe 5 to 15 minutes, and combine them with long-lived refresh tokens that are stored in a secure HTTP-only cookie. This way, the access token can be used for fast, stateless API calls, but every 15 minutes, the client has to exchange its refresh token for a new access token. During that refresh step, the server can check the database to see if the user is still active, if their permissions have changed, or if the session has been revoked. This gives you the best of both worlds: high performance for most requests, but a guaranteed security check every few minutes. If you must use JWTs, follow these rules. First, never store them in local storage. Use cookies with HTTP only, secure, and same-site strict flags. Second, use a library that forces you to specify the allowed algorithms so you don't fall for the none trick. Third, keep your payloads small and non-sensitive. And finally, ask yourself, do I actually need statelessness? If your app only has a few thousand users and runs on a single server or a small cluster, session cookies in a Redis store are often simpler, more secure, and easier to manage. Don't let the cool factor of JWTs lead you into a security trap you'll regret later. Engineering is about picking the right tool for the job, not the most popular one. Thanks for watching. If you found this breakdown helpful, hit that like button and subscribe for more deep dives into technical architecture and security. See you in the next one.